In this video I'm going to show you how you can repair this and how you can repair and improve similar things yourself. Hi there, I'm Tom and you're watching 3D Printing Geek. Owning a 3D printer enables us to do things which were impossible to do for us before. Like improving or repairing things in and around our homes instead of crashing them.
Welcome to my garden. Today I'm showing you what happened. I have two LED lights and unfortunately one has been blown over by the wind.
For such an easy object like the light bulb, which is only a sphere which is hollow and cut on the bottom side, I'm using 3D Builder. First I add a cylinder which will be the strengthened opening for my bulb and set its size to 30 mm. Then I add another cylinder, which will make the opening in the first cylinder, and set the X and Y dimension to 26 mm. Finally I move the second cylinder a little bit down and subtract it from the first one. Now I set the height of the first cylinder to be 3 mm, which will be fine for the opening. Finally I set the position of the ring to 1.5 mm, which is half of the 3 mm height which I choose for the ring. To create the bulb I insert a sphere and set the diameter of the sphere to be 60 mm, which is the diameter of the original bulb. Last but not least, I have to cut away a little bit from the bottom of the sphere, which I can do using the split tool, moving down the splitting plane by 27 mm. We have our bulb. I will save this as a 3MF and import it into Cura. In Cura I select all models and center it on the build plate. To make the bulb hollow I will set the infill to 0, and to make sure that the bottom is open I set the bottom layers to 0 also. The printing temperature of 230 degrees, which might seem a little bit high for PLA, but as I'm printing transparent PLA, that's fine. For transparent PLA, printing at higher temperatures makes the transparency a little bit clearer. I also crank up the print speed, in my case to 120 mm, which we won't reach at any point during the print. When we slice the model with these settings, we'll see that our ring, which we introduced to strengthen the opening, will be printed with no infill, which is not what we want. And that's finally the reason why I chose the 3MF format to save my model, because this format keeps all objects of a model as they are. As you can see, I can select the sphere separately from the ring, which is strengthening the opening. By using the per model settings, I'm able to choose another infill for just that part of our print. Here I set it to 100%. When we slice the model again, the ring now has infill but the bulb not. Time to save the model to disk and print it. Before revealing the final result, here are some inspirations on things which can be printed using a 3D printer to improve or repair things. Which things did you already repair or improve using your 3D printer? Let me know in the comments down below, and please give my like button a hit. I bumped into the cabinet handle while vacuuming and it broke off. Because I had no replacement at hand, I created my own. To fix it, using Fusion 360, I unmounted a handle which wasn't broken and took some measurements from the original part. And then was able to replace the broken part with the printed part, and everything works like expected. Here you see the case which I printed for a stepper motor analyzer to enclose its electronics. And if you're interested in seeing how the stepper motor analyzer works, make sure you subscribe so you don't miss out when I feature this in one of my upcoming videos. There was also this sign which is on the door now, and it only had this hole on the back to mount it, but I didn't want to use a nail in my door. So I printed 2 hooks, which you can see on the back. Now I'm able to mount a line to hang it on the door. To prevent my FTDI USB to serial converter from shorts when working around on my table, I printed this little nice enclosure, so it's safe to work with it. This is a solar panel which I wanted to mount at a higher point in my garden so that it gets enough sunlight to load the batteries. This is a little holder which I printed to put on the post, and finally can slide my solar panel on top of it. The brackets on my 3D printer holding the stepper motors, and here are the replacements I printed to lower the Z-axis. And here's the final result. I hope you enjoyed the video. See you next time.
Now I will put the printed one on the other lamp so you can see how it looks like.